Welcome to Learner's Prep. In this session, we'll solve some more problems based on the concept of LCM and HCF. This is the third session in this topic. Now, let us solve question number 31. Find the greatest number which divides 725 and 589, leaving remainders 5 and 9 respectively. So to find the greatest number which divides these two numbers, we have to find out their HCF. And there should be a remainder of 5 and 9. So we have to subtract 5 and 9 from these numbers. From 725, we have to subtract 5. 725 minus 5 is 720. Similarly, from 589, we need to subtract 9. So we get 580. So we have to find out HCF for these two numbers. So to find out HCF, we have to divide both the numbers simultaneously by a common number. 580, 720. So both these numbers are divisible by 2. The smallest prime number 2. This is divisible 290 times and this is divisible 360 times. Now again both of them are divisible by 2. This is 1, 4, 5, 145 times. 360 is divisible 180 times. Now these two numbers 145 and 180, they are not divisible by 2, they are not divisible by 3. Next, they are divisible by 5. So 5 2s, 5 9s. Then again 5 3s, 5 3s 15, 30 remains, 5 6 30. 29 and 30, they are co-primes. 29 is a prime number, it is not divisible by any number. So therefore, the common divisors are 2, 2 and 5. So that is the HCF. So HCF is equals to 2 multiplied by 2 multiplied by 5. That is 2 to the 4, 4 5 is 20. So 20 is the HCF. So that is a number which divides 725 and 589, leaving remainders 5 and 9. So first we have to subtract the remainders and then find their HCF. So that number divides, leaving those remainders. So correct answer is option 4 5 is 20. Correct answer is 20. 2 to the 4, so 4 5 is 20. 20 is the answer, sorry. So 20 is the correct answer. Option D is the right answer. Question number 31. Question number 32. The product of two two-digit numbers is 2352 and their HCF is 14. What are the numbers? So let us assume the numbers as 14x and 14y. Because 14 is a HCF, x and y are co-primes. So non-common factors are x and y. So they are co-primes. So the common factors product is 14. So let the numbers be 14x and 14y. So their product is 2352. 14x multiplied by 14y. Their product is 2352. So if you multiply, you will get 14 into 14 into xy is equal to 2352. So xy is equals to 2352 divided by 14 multiplied by 14. So let us cancel it by 7. 7 2s, 7 3s, 21, 25, then again 7 3s, 4 remains 42, 7 6 are 42. Again by 14, 14 2s, 28, 5 remains 56, 14 4s, 56. Again 2 12s, 24. So the remaining is 12. So xy is equals to 12. Product of x and y is 12. So that means x and y are co-primes. So what are the factors of 12 which are co-primes? So the factors of 12 which are co-primes are 1 and 12 and 3 and 4. So if you consider 1 and 4, their product cannot be 2352. So product of the numbers cannot be 2352 if you assume x and y as 1 and 12. So another pair of co-primes is 3 and 4. So that is the only possible. So what are the numbers here? 14x and 14y. 14x means 14 into 3, that is 42. Then again 14 into 4 is 56. So these two are the numbers, 42 and 56 are the numbers. So answer is option B is the correct answer. Question number 33. Find the greatest number which divides 98 and 62, leaving the remainder 2 in each case. Same case, we have to subtract the remainder first. 98 minus 2 is 96. 62 minus 2 is 60. So after subtracting the remainder, now we have to find out HCF. HCF of 60 and 96. 96 and 60. So divide both of them by the common divisor. They are divisible by 2, 30 times, 48 times, again by 2, 15 times, and 24. 15 and 24 are divisible by 3, 3 5s, 3 8s. 5 and 8 are co-primes. So HCF is common divisors. What are the common divisors here? 2 multiplied by 2 multiplied by 3. 2 2s are 4, 4 3s are 12. So 12 is a HCF. So 12 divides 98 and 62, leaving remainder 2 in both the cases. So 12 is the correct answer. Option B is the right answer. Question number 34. Find the greatest number that divides 65, 101, 173, leaving the same remainder in each case. So here remainder is not given here, but it is mentioned that it is same. So the logic to find out the HCF is, so the greatest number that divides these three numbers leaving the same remainder divides the difference of these three numbers leaving the same remainder, leaving the remainder 0. So we have to find out the difference between the three numbers and find out their HCF. So what is the difference between these three numbers? 65, 101, 173. So that first of all, let us find out the difference between first and second numbers. So 101 minus 65. So is 36. and 101 and 173. The difference is 72. And 65 and 173. What is the difference? The difference is 108 is the difference. 108 is the difference. So these are the three differences between the three given numbers. So we need to find out HCF of these three differences. So that divides these given numbers, leaving the same remainder. So HCF of 36, 72 and 108. So let us divide these three numbers with a common divisor. 36, 72, 108. So the prime number, lowest prime number 2, it divides all the three numbers 18, 36 and 54. So again divide by 2, divides all the three numbers 2 9s, 2 18s, 2 27s. Now 2 cannot divide 9 and 27. So all the three numbers are divisible by 3 here. So divide all the three numbers by 3. 3 3s, 3 6, 3 9s. So again all the three are divisible by 3. Once, twice and thrice. So 1, 2 and 3 are co-primes. Now the common divisors are 2 into 2 into 3 into 3. So this is 2 2s are 4, 4 3s are 12, 12 3s are 36. So HCF of all these three numbers is 36. So 36 divides the three given numbers, leaving the same remainder. So that is the answer. Option C is the correct answer. Question number 35. Two numbers are in the ratio of 5:7. Their LCM is 420. The smaller of the two numbers is what? So the numbers are in the ratio of 5:7. So that means the non-common factors are 5 and 7. So they should be multiplied by HCF to get the original numbers. So let the numbers be 5H and 7H. So H is the HCF of both the numbers, 5H and 7H. So product of these two numbers, 5H and 7H, is equal to product of their LCM and HCF. So LCM is 420, HCF is H. So let us simplify this. You can cancel H on both sides. So now what is remaining here? Left side H is remaining. 420 divided by 5 into 7. So this is 760 times. 760 times. Then again 512 times. So the remaining is 12. HCF is 12. So smaller number is 5H. Smaller number is 5H. 5H. So 5 into 12, which is equal to 60. 60 is the smaller number. The greater number is 7H. That is 7 into 12. 84 will be the greater number. 60 is the smaller number. So the correct answer is option B is the correct answer. Question number 36. So this is also a similar question. Two numbers are in the ratio of 4:7. Their HCF is 6. Their LCM is what? So let the numbers be. So let us assume the numbers as 4H and 7H. So H is given here directly 6. So therefore we can directly find out the numbers. So numbers are 4 into 6 and 7 into 6. So 24 and 7 6 are 42. So these are the numbers. So we need to find out their LCM. So directly you can find out, or you can divide their product with HCF. So LCM is equal to product of the numbers by HCF, or directly also you can find out the LCM. So both the ways you can find out. So this is 6 fours 24, 6 fours 24. So what is remaining? 4 into 42. 4 into 42 is 168. So that is the LCM of numbers, 168. Or directly also you can find out LCM for 24 and 42. You get the same answer. So correct answer is option B. Next, question number 37. The product of the LCM and HCF of two numbers is 980. The numbers are in the ratio of 5:4. What is the sum of the LCM and HCF of the numbers? Same thing. Again here we should assume the numbers as 5H and 4H. So let the numbers be 5H and 4H. 5H and 4H. So directly product of LCM and HCF is given. So you can equate it to product of the numbers. 5H and 4H is equals to 980. So this gives H into H is H square is equals to 980 divided by 5 into 4. So if you cancel it, 5 ones, then again 5 ones, 4 remains 48, 5 nines are 48, 5 nines are 45, 3 remains 30, 5 6 are 30. This is 4 fours 16, 36, 4 nines are 36. So the remaining is H square is equals to 49. H is equal to square root of 49. Square root on both sides. So you will get H is equal to square root of 49 is 7. So HCF is 7. So now if you divide LCM and product of LCM and HCF with HCF, you will get LCM. So LCM is equals to, what is the product of LCM and HCF? 980 divide with HCF 7. So that is 7 ones, 7 fours, 140. So sum of LCM and HCF. So HCF plus LCM is equals to 7 plus 140. That is 147. This is the answer, 147. Option D is the correct answer. Question number 38. The sum of two numbers is 420. Their HCF is 21. How many pairs of such numbers can be formed? Sum of two numbers is 420. Their HCF is 21. So let us assume the numbers. Let the numbers be 21x and 21y. So non-common factors are x and y. Product of common factors is 21. So sum of these two numbers is 420. 21x plus 21y is equals to 420. So if you take 21 common, x plus y is equals to 420. So x plus y is equals to 420 by 21. This is 2 times 21 twos and carry 0. So x plus y is equals to 20. So x and y are co-primes. They are non-common factors. X and y, because they are co-primes. So how many co-primes are there whose sum is equal to 20? So x and y can be 1 and 19. X and y can be 1 and 19. Their sum is 20. And they can also be 2 and 18. X and y. So I will write here x and y. So 3 and 17. They can be 4 and 16. X and y can be 5 and 15. They can be 6 and 14. X and y can be 7 and 13. Or they can be 6 and 12. Or they can be 7 and 7 and 13 over 5 and 15. Or they can be 4 and 16. They can be 3 and something is missing here. After 7 it should be 8. They can be 8 and 12, 9 and 11. They can be 10 and 10. So then again it will repeat 11 and 9. So here let us find out the values of x and y which are co-primes. So here 1 and 19, they are co-primes. So x and y can be 1 and 19. So they cannot be 2 and 18 because they are not co-primes. So x and y can be 3 and 17, they are co-primes. They cannot be 4 and 16 cannot be co-primes. 5 and 15 are not co-primes. 6 and 14 are not co-primes. 7 and 13 are co-primes. So 8 and 12 are not co-primes. 9 and 11 are co-primes. 10 and 10 are not co-primes. So here x and y are co-primes. X and y are co-primes. So how many such pairs are possible? 1, 2, 3, 4. So 4 pairs are possible here. So how many pairs are possible? 4 pairs. 4 pairs of such numbers can be formed. So 4 pairs is the correct answer. 4 is the right answer. Option C is the correct answer. Question number 39. The product of the LCM and HCF of two numbers is 72. The difference between the two numbers is 6. What are the numbers? So the difference between the two numbers is 6. And product is the product of their LCM and HCF is 72. So let us assume the numbers as x and y. X and y, let us assume. The difference is x and y. X minus y is equal to 6. Product of LCM and HCF is 72 and the product of the numbers is also equal to 72. Because product of the numbers and product of their LCM and HCF both are same. So product of two numbers is 72. So let us find out the factors of 72 whose difference is 6. So what are the factors of 72? So let us write down the factors of 72. So with a difference of 6. So you cannot take 1, 2 or such small numbers. Let us start from say 4. 4 and we'll write here x and y. 4 into 18. 4 into 18. 4 and 18 are factors of 72. So 18 4s are 72. Or otherwise we can directly take here 18 and 4. So what is the difference here 18 and 4? The difference is 18 minus 4, it is 14 is a difference. But the difference should be 6. So next pair of factors. It is not divisible by 5. So it is divisible by 6. So 12 6 is 72. 12 multiplied by 6 is 72. So what is the difference of 12 and 6? 6 is a difference. So that means we can assume x and y as 12 and 6. So x is equal to 12 and y is equal to 6. Their product is 72 and the difference is 6. So 12 and 6, these are the numbers. Option A is the correct answer. Question number 40. HCF of two numbers is 6. Which one of the following cannot be their LCM? So always you can remember that, you should remember that LCM is equal to a factor of, LCM is a multiple of, LCM is a multiple of HCF. LCM is a multiple of HCF. We should remember this fact. LCM is a multiple of, LCM is a multiple of HCF. So we should check the options which is a multiple of HCF, which is not a multiple. So first option, let us check 18. So 18 is divisible by 6. So this can be the LCM. 18 can be the LCM. So the question is which cannot be the LCM. So 18 is divisible by 6. 18 is a multiple of 6. Next 30. 30 is also divisible by 6. It is a multiple. Next 36. 36 is also a multiple. And 45. 45 is not divisible by 6. 45 is not a multiple of 6. So option D is the correct answer. That cannot be the LCM. So 45 cannot be the LCM. So 45 cannot be the LCM. Be the LCM of numbers. So correct answer is option D is the correct answer. So these are the problems based on the concept of LCM and HCF. We will solve some more problems on the concept of LCM and HCF in the next session. Thank you.